Hello friends, this is Ganesh and video number 2 on use case scenarios. In this video, I'm going to explain the concept or a methodology called parallel processing. So many times we just arrive to a situation where we need to implement a parallel processing for a long running program or a report. So today we're going to see what is the steps we are going to implement to achieve the parallel processing for a program. And most of the time, I can say it's normal ABAP coding only. Maybe few syntaxes, new syntaxes while calling the function module. Apart from that, we are going to learn few new transactions which is related to the basis, especially for identifying what is the RFC group name, what are the processes are available to run your program. So those things we are going to see in this video. And parallel processing, most of you people aware of it. What is parallel processing? So we are going to execute a same set of code in different processes. Okay, a program contains a lot of code, and a set of code is going to repeat, or it's going to be run more time. It may be a loop or data manipulation or updating a table in a backend, whatever it is. So, but to identify the particular set of code where it takes long time to run in the program. So we're going to keep that set of code in a different function module, and I'm going to execute it in different processes or different sessions, very simple. So that is the idea of parallel processing. So we'll see how we can implement the parallel processing in our normal ABAP program. Okay, let's get into the slides. So first thing is why or when, not why, when the parallel processing is required in your daily development. Whenever there is a performance issue arises of an existing program, then normally we just think, why can't we go with the parallel processing? But most of the cases, we are not start the parallel processing immediately. We try to include the standard performance measures. We try to analyze the program and implement our standard performance parameters, especially in the select, loop, or just delete the unwanted code, and then try to change the design of your program. Instead of fetching more than two tables, try to change the way how we are fetching, and now we have different views are available. So we're trying to implement our new technologies like new syntaxes. So everything we tried. Okay, so we try, and even after implementing all the performance measure, still the client is required this needs to be run faster. So in that particular situation, we decided, okay, we'll go with the parallel processing. So that is the normal step. So it's not every time immediately jump into the parallel processing. We try to achieve the basic performance measures in the existing program. And that actually helps to run more faster the parallel processing. So instead of directly go to the parallel processing, try to just cover or modify the existing program with the actual performance measure. That will help the parallel processing run more faster. Okay, and yeah, the last one is like after the performance measure, we decided still we need more performance needs to be improved. Then we go with the parallel processing concept. Okay. And a few things to be considered before decided to the parallel processing. The set of code we decided to run in a multiple sessions that needs to be executed independently. It should not wait for something else to be done in the program, then only it will start. It would stop. So in that cases, don't those kind of codes is not advisable to keep it in the parallel sessions. Okay, because the same set of code is going to run in multiple sessions at the same time. Okay, that's the reason I'm saying it should not depend on something else, and needs to be available in the parallel process. Meaning, I have a process because this is not only the program which is going to be run in multiple sessions or multiple processes. Many programs, many background jobs, many standard programs are using the same processes in quality, especially in the production system. So our program is also one of additional object for the processes which is going to be used. So we have to consider, it's like I'm going to use all the processes, whatever it is available. That is not an advisable way, because once you occupied all the processes, The remaining objects are still waiting if the process is not available. So these are the basis criteria, basis place where we have to think and make sure it's not affect the existing or any other objects, which is also depends on the processes concept. So that also we need to be consider. I'll show you how we can decide how many process we can use it. We have to wait or not. So those things also we have to consider before starting your parallel processing concept. And then perform the function model without the addition of parallel process. The meaning would be design your function module. The piece of code is going to be in the function module, and make sure the piece of code is working perfectly. So just call the function module in a normal mode without parallel processing. Make sure it's working fine, especially the conflicts and all. If you create an import export parameters, tables parameters, sometimes what happens, it might give a conflict error. But if you without testing the function module, normal function module without parallel process, if you try to execute it, even if there is any conflict issue between the import and export parameters, it won't give the proper information, proper runtime error or something. So that is the reason I'm saying at least one time tested your function module properly. Yes, it's working fine, no conflict issues. Then enable the parallel processing for the same function module, just for your reference. Okay. And then this is the idea which we are going to implement in the parallel processing. A program is going to run with 1,000 records. It's very minimal. So normally in real time, the data volume is huge. But data volume is also plays a major role for the performance issue. And whatever performance improvement we can implement with the existing code, because of the data volume, we are not able to achieve whatever is required. So that is one of the reason we decided to go with the parallel processing. So program with runs with 1,000 records. So I'm going to divide it into 250. It's a hard coded division here. So I'm going to use 4 processors. So I'm 250 in one, 250 in another one, and remaining 500 is also split in 250, 250. So this is the entire, the decision is, everything is depends on your own experience or your own scenario. So it's not like always go with 4, it's not like always go with 1,000 records. So you can decide after 10,000 only I need a parallel processing. So the entire data logic is depends on your own scenario. You have to decide it, how many processor, how you are going to divide the entire data volume into packets. Technical term we call it as packets. So 1,000 is divided into 4 packets. Each packet is 250. So it's going to be send the same function module, but it's going to execute in a different processor. 4 times the same function module is going to execute by using different processes. Okay, so this is very hard coded one, but things are decided in your based on your scenario in your program. And then steps, how we are going to do what? We need an RFC function module. So normal function module is not work for parallel processes. You need a RFC function module, even though if it is going to call from the same server. And you need to find the server group name with the help of the transaction called RZ12 is a transaction where you're able to see the server name, group name, I can say. In test system, you don't find any group name. By default, you will find some group name with the numbers, normally 360, 390, 370, some numbers. So that actually won't work. We need to create one group. This is only for test system. But normally in your client side or customer side system, you have the group, especially for the parallel processing or parallel generators. Normally they call it as, even the names also they just keep parallel underscore generators group name. So you need to identify what is a group name on your server, and a dynamic task name to be populated. Every process is called a task technically, so you have to generate dynamically the task name as well. Suppose 5 or 6, so it's simple, it's a count, increase the count. So if suppose a PO1 is a name PO and 1 is the dynamic number generator, so PO1, PO2, PO3, PO4. So like that you need a unique task name for every session, every processes. Okay. And then okay, syntax detail. So simple, call a function module, because the set of code is going to keep in the function model, RFC function model, that needs to be called in your program. So you know what is the syntax to call a function module. In that there are some new lines to be added. The first thing is call function, same name for function module name, and starting new task. The task name I mentioned, the unique task name to be identified. That is also decided by you only, task name. Destination in group, the group name which we identified from RZ12, or you can check with your basis because sometimes you don't have authorization for RZ12 transaction, and you have a table also. Suppose you don't have RZ12, there is a table. I hope it's not mentioned here. I'll show you in the system. There is a table where you are able to identify what is a group name which is associated with your server. And then performing subroutine name, any name you can give. So we need a subroutine because after the function, what needs to be done, that is going to be entered or a key in that particular subroutine only and on end of the task. So this is the syntax to call a function module, and it's going to be run in multiple sessions. Okay, so this is going to be okay. The next one I'll explain. So this is the first syntax, it's a full line. Okay, so there is no dot or comma, it's a full line. And then the next one is the subroutine. Inside the subroutine, you have to create the subroutine in the same program, form and inform. Inside, I'm going to receiving the result. So this is going to start. It's not because it's a parallel sessions, right? I'm not going to wait. I'm not going to wait once the parallel session is done. Not wait here actually in the main program. That is going to happen in the subroutine. So inside the subroutine, I'm going to receive the results from this function module. So receiving results, what you are going to send, everything depends on your scenario. So I'm sending 2 internal table data and receiving 1 internal table data as a final data. So it depends on you. Okay, so that is going to be received inside your subroutine. So receive results from function module name, import export parameter based on your design. Another one is I'm going to keep this one inside the do and end do, because it's going to be determined based on the available processor, depends on your own scenario. Like you can hard code it 5 processor, 3 processor, or the processor you can get it from the user input. A lot of things are available. So this is going to be in the do and end do. Okay, and we have to conclude a do and end do because it's an infinite loop. So you have to conclude when you have to exit do and end do. So this is not going to be do 5 times, do n times, because it depends on the process as well. Okay, and maybe depends on the process, you can able to make it do 5 times, do 6 times, but mostly we go with the infinite loop and have a logical condition to come out of the do and end do by using exit keyword. And you have to use the concept called wait until, meaning here this is going to be generate the processes. Okay, maybe a 4 or 5, whatever it is. And for example, I'm going to stick with the example 5. Okay, depends on that. 5 process is going to run, and it's going to be run. I need to wait until all the 5 processes are completed. Okay, so that is the reason you have to write a logic over here. Wait until all the processes are done, which is equal to whatever processes got initiated. So 5 processes got initiated, then I have to wait all the 5 processes to be completed. For that, I have to write the logic wait until. It's very simple logic, greater than or equal to. I'm going to have 2 different variable, global variable. I'm going to increase the count for every initiate of the process and every complete of the process. So then I'm going to compare the value of the actual as well as the processed variable. Simple. Okay, but wait until is the keyword, you have to use it. Okay, and then yeah. Own logic to segregate the data, so yes, and decide the number of processing that I have mentioned already. The logic to segregate the data, how you're going to segregate your data. So I'm going to take very minimal amount, probably you convert it for your own need. 1,000 records I have. So how you're going to segregate, either 250 is a standard one, or depends on the company code, or I'm going to send only the plan 4,000 in one batch, 4,019 another batch, or depends on the company code I'm going to send. It's up to whatever design you need. Okay, and the same thing for decide the number of processing. So in my experience, one of the parallel processing, we have received the number of processes because it is the most priority of the object is most priority. So we can give maximum 32 processes they can able to use it. So we give the option in the input screen itself. Normally they go the background job, so they can use 30, 25, whatever it is. Maximum they can use 30 or 32 only. Okay, so that is the one. Another one is depends on the availability. We are using -1, how whatever process is available, we can use -1. And sometimes we used a hard-coded processes. It's a low kind of object, data volume is not more, but it needs to be run more faster. So we go with 3 maximum. So the processes is going to be up to your design, up to the availability also. Please have a word with your basis as well whenever you're going to use the parallel processing concept. Okay, regarding the processes. And yeah, this is the one function module where you have to identify for your group, for your server actually, how many processes currently available before you start the do, before you start this code using this function model, you can identify, okay, how many processes are free actually, okay, 3 processes are free, 30 processes are free, so I can use 10, I can use 5, that you can decide. And this is one of the function module to find how many processes currently available. Okay. And what else? Okay, my scenario. I thought I'm going to give the PO with delivery information. Unfortunately, my ECC is not working for last few days, ECC system. So I have to go with the HANA system only for this parallel processing. And HANA system, I don't have any single data in LIKP and LIPS. So what I have decided is I'm going to get the PO details. Even I have very less data. So I'm going to manipulate the data using the do loop. I'm going to get the PO details, and my scenario would be I'm going to get the material description and company code description, plan description, and storage location description. So 4 different database table I'm going to fetch in my parallel processing, and I'm going to map the informations as a final input, final internal table. So what material number, company code, sorry, material description, company code and its name, plant and its name, storage location and its name. So this is a scenario which I'm going to use in my this particular video. So hope you have a basic idea of parallel processing, what are the things to be considered and what are the syntax and everything. I will show you in the system as well. Okay. Yeah, one more slide. Okay. The transactions like SM66 and SM50 to check the parallel processes, you're able to see how many processes are running, actual your own processes are running over there, and to compare the execution time in detailed, either excuse me, either you go to SE30 or SAT to compare before parallel processing how much time it took, and after parallel processing what is the time taken by the program, so that you are able to check either any one of these transactions. Okay, is there anything else? No. Okay, that's it. Let me take you to my system. So okay, this is my program, and it's very simple. I get the information from EKPO table, and this table has very limited data. So that is the reason I'm just trying to increase the data volume by doing this do like 2 lakhs time. Okay, so this is actually an option. This is not at all happening in your real time, so forget about it. This is only to increase my data volume, so I just used it. Okay, and I have my function module. It's also already built because these are very normal ABAP code, so I don't want to take much of your time, so that is the reason it's ready. So this is the code where imagine this is a code where it's available in the program. It takes more time, so I decided I just move those set of code in a function module, and the function module is designed using RFC, remote enable function module. Remote function call, yeah, RFC remote enable function module, and I have very simple informations. I'm going to receive the PO details from my program, whatever the fields I have shown, right? This is the one. These are the fields I'm going to get it from the program, and based on that I'm going to get the detailed information, and that is going to be updated in this final data. So very simple design. So this is the input for me and this is the output. So the structure, if you see, it's very less details here. I have only 6 fields. I'm getting these fields as an input to my function module, and while sending back I'm going to add probably 4 additional new fields which holds material description, and this is the one, material description, company code name, plan name, and storage location. So this is my output of the function module. Okay, so this is going to be executed independently by different processes. Okay, display, and the code is also very simple. If it is not initial, I'm getting the information from the relevant table, MAKT for material, TU001 for company code, and end with W for plant, and end with L for storage location information. So once I received all the information in a different internal table, I'm going to loop it and read it because I want to give more data manipulation. That is the reason I just returned the very basic normal ABAP code. So even you can achieve this in a different way as well. Okay, so this is only for the practice. I used a very normal ABAP code, like again loop, read it, and everything. You can go ahead with the new ABAP code as well. So to information, get the information from the another internal table, and finally I'm going to append it to my final data. Okay, so it's a simple one. So now what I'm going to do is I'm going to call this function module with the parallel processing from my program and see the output. Then we'll try to implement the code. So Control F6, call the function module. This is the way you have to do it in your side. Make sure you're not getting any issues, especially the type conflict will come. So what I'm going to do is I'm going to give ekpo temp, and I need a data to receive, right? Final. So final need to be declared. Okay, it's declared here based on the table type which I have showed you. Okay, simple. And let me have a breakpoint. So this is I'm going to do it without parallel processing. Okay, so normally have this even in your side also. It needs some take some time because of this do. Okay, it stopped, and excuse me. So this much record, actually repeated record I can say. And these are the things which coming from the inside the function module, MATX, and company code name, plan name, and storage locations. Okay, so hope I get normally 16 records or 20, I'm not sure. Yeah, I believe we are 23 records I have EKPO, then it started repeating so because of my do statement. Okay, so now let's see and how to implement the logic. So here what I can do is, so let me keep this aside by putting like if 1 equal to 2 and end if. So I don't want breakpoint here. So let's have it later. And changing the name of the internal table for little clarity. AKPO source. Okay. Okay, almost done. So what I'm going to do is let me introduce a do, and this is going to be an infinite loop. Okay. So first I'm going to get number of records from my source table. So IT KPO source lines data local variable total records. Got it. And there is a scenario where we can decide the total number of records is more than 10,000, more than 1 lakh, then initiate the parallel processing. Suppose it may happen, right? This source is also going to be uh, deleted, means remove the data based on how much we are populating the each packet. For example, you have 100 records, each packet is going to be 20, then every iteration, every do, it going to be removed the 20 record which is already sent to the parallel process. Okay, that needs to be removed. Suppose if it is not 103 records divided by 5, you will get only 3 records, right? And that's the case. What I can do is if it is very less record, we are not using parallel processing. So what you can do is you have a condition here that you can decide if total number of records is greater than 10,000, then you decide I want the parallel concept logic. Otherwise, just go with all the 103 records in one stretch. No need to go with the more than one process on it. Okay, so that way you are able to do that as well. So here what I'm doing is I'm not going to do that here. Let me go with is not initial and sy index. So the first time I'm just show you how it is happening. My own logic is how it's happening. Then we can modify this also. It's greater than 10,000 only. You got to work. Less than 10,000, please don't go with different. Get the data into many process. Just one is enough. So total record is not initial and index equal to only one. Then I'm going to have get the data like data, and I need some data variables per. Okay, this is actually packet count is nothing but total records divided by 5. So here also I go with hard-coded process. Okay, we'll change little later, and here LV lines. Okay, I can say packet count, right? Okay, lines to be deleted from the packet. Okay, so it's nothing but LV packet count plus 1. So idea is, suppose I have 100 records, and if I divide it by 5, it comes to 20, and I'm going to remove the record from 21st position for 21st record. That is the reason I'm adding plus 1 here. Okay. Then else if, so as I mentioned, you can go ahead with your own logic also for data segregation. So if total record is less than LV lines to be deleted, then just clear it. Deleted. Okay. So now I need some internal table which carries the data. So I can say it's PO packet is nothing but we'll get the details from the source table it akpo source. Now if LV lines to be deleted is not initial, then only I'm going to delete it. So what I'm going to do is I'm going to ask the information system to delete the details from this internal table. These are the two internal tables, source and what is the internal table which carries your actual data is very important here. From lines to be deleted. So lines to be deleted is from 21st record as an example. That's it. So what happens here, it carries all the 100, and this one it's delete the details from 20 to 100 records. So line from this one, so 21st going to delete, and this one carries 20 records. Okay, so almost we are close. What else to be done here? Nothing. So we decided what is the packet size is going to be, and what happens if it reaches suppose 20 or is going to be 19, suppose 103. So then what happens is the 3 it comes here, 3 is less than lines to be deleted. No, what happens? Okay, it's less than, yes. So here what it will check the last 3 records, right? So 3 is less than lines count as 21. That's what I'm saying. It needs to be happen only one time. So this time what happens? Yes, and this is going to be deleted, and here it going to be only 3 records going to be moved to your another internal table, and this is not going to happen because this got initial. It's not got initial. It's deleted it. So it's going to be initial. This is not going to be work. So only 3 records is going to be carry forward your last processes. Okay, so that is the idea behind this logic, and let me call my function module now. Okay, so okay, let me have this. Anyway, this is optional, leave it, and here it PO packet, this is what I'm going to send. So the syntax is the first line starting new task. So new task, I want to know what is the task name. So task name is going to be GV task name. So here on the flow, I'm going to declare the variables, whichever is required. I'm not declare everything at one time. So here go up and declare it. So I need two variables here. One is for count, one is for task name. So task name, both are character data type. Hopefully character 20 depends on how what task actually you are giving. And count is also type, not more than that. So let me hover 3. That's it. And task count is going to be added in my do loop. Inside the do loop, I'm saying gv task count is equal to gv task count plus 1. Okay, and here I'm going to generate my task name. So concatenate, it's going to be a PO1, sorry, PO and GV task count into GV task name. Okay, so task name is done. And then the next one is I'm going to use the destination and group. I need the group number, sorry, group name. So group name is available in the transaction called RZ12. Okay, so here you are able to see the logon group and the instance. So most of the instances are same here, but this is the instance of the server and this is the parallel processor name of the group. Normally by default you will get some 360, 390 some numbers, but that is not going to work. You have to create it. Mostly in your client system or your real system, these are already done from the basis people. So please touch base with them. And if normally you don't have authorization for this RZ12 in your real system, that is the case, you have to get the names from them only. If it's a test system, just play around. Okay. And we have one more thing. If you doesn't have an authorization, just for a reference, there is a table called RZLL ITAB where all the group names are maintained. Okay. So here class name is nothing but the group name. So I want this group name to be added in my program. So in group, this is the group. Okay, and finally I need one more performing. I need a subroutine where I'm going to write the code. Subroutine for final data and is going to be on end task. So this is the syntax which I have to write to call my function module with a different task name under this RFC group name and performing sub final data where I'm going to receive my final data, okay, in the subroutine. So far you're able to follow and ITU packet and everything is fine. Here I'm not going to receive the final. Final is going to be received only in the subroutine. Okay. So subroutine will do little later. So what is the next step is I need to decrease or delete the information from the source because as per this example, so 20 records are already passed for the session 1, process 1. That first 20 records to be deleted from my source internal table. So for that I have some logic to be done. So what I'm going to do is if LV lines to be deleted is not initial, then what I'm going to do is data LV lines delete from source. It's nothing but LV lines, because now LV lines is, as per our example, it's 21, but I want to delete only first 20 records. That is the reason I just go with -1. So here I'm saying delete my source table ekpo source. Let me go little, yeah, source from 1 to LV lines del from source. So what happens here? It will delete the details from 1 to 20. So first 20 records which we shipped, means in the sense which we send to the session 1, that needs to be deleted here. Okay. Suppose if this is not initial, here it is initial, meaning in some cases we are clearing the information, right? Clearing clearing this variable. If it is cleared, what I have to do is I need to clear it ekpo source. So example, the last three records, it's going to be last three records, then this is actually a deleted one. Then the last three records also to be deleted from this source internal table, because this needs to be the key for us to come out of your do loop. So if IT source is initial, then please exit the do loop. Okay, so almost we are done with the do and undo. So here what happens, this will create number of process based on your calculation. It creates a number of processes. Okay, almost done. Then let me have a wait statement here. So before wait statement, let me have the subroutine. What is the subroutine name? Sub final data, right? Final data. And this subroutine has one mandatory parameter, formal parameter, that also needs to be declared here. P underscore task name. I'm not going to use it, but anyway, that needs to be, added. So here there is a syntax I have already shown you. Receiving details, results from the table, sorry, from the function module. And let me copy this. Okay, I don't want the source here, just a final. Okay, that's it. I want the information, and this is for every process. So this subroutine is going to be executed for every process. Five process, five times is going to be get the result of the same internal table. So I need to get it in the temporary internal table. Then finally I use append lines of this final temp internal table to IT final. So now I need to declare the final temp internal table. IT final is already declared. So IT final temp with the same table type, CGI data. That's it. So data segregation is done with do and some logic, and decided how many process is a hard-coded one. And then every process is going to be 20, depends on if it is 100 is 20. Okay, depends on the data is going to be struck. 1 second. Yeah, it's struck somewhere. Okay. So our lines to be data will be segregated, and the process we decide for only 5. So almost done, and we are handling the source information also. Okay. And subroutine, we are receiving the information. Finally, the informations are going to be stored in the final internal table. So one more step to be pending. So these are executed normally. It won't stop. Okay, but we need some break where we need to make sure this program to be executed, or program to be wait until it process all the processes, all the sessions. If it is 5 process, 2 process, 1, whatever it is, this program has to wait. Okay, as per the current code, it won't wait anywhere. So what I have to do is, after the do an undo, I need to use a concept called wait until. Okay, what is the logic? Logic is very simple. How many process initiated and how many processes completed? So that is the one. So that I'm going to use with the help of two variables which I'm going to declare. First, I'll make use of it. GV processed is greater than equal to GV initiated. Okay, simple. So if I initiated 5 and process also 5, then stop. Until means then wait. Until that you have to wait. Okay, so that is the concept here. So these two to be declared, and we need to count, use the count. We have to give some values also. Let's do it one by one. GV initiated type I, and then GV processed type I. Okay, that's it. So initiated is going to be have a value after every initiation happens. So here it is. After this happens, I'm going to do GV initiated is equal to GV initiated plus 1. Simple. And the processed, maybe a spelling mistake. So processed is nothing but after it receives the value to the final internal table, I can consider it processed. So processed is equal to GV processed plus 1. That's it. Almost we are done, I believe. Let's see any issues or something. Source is unknown. Okay, I think I renamed it, right? Okay, here it is. Source. Anything else? Yes, statement is not accessible. Oh, okay, it's a subroutine. After subroutine, I kept. Okay, let me take this and keep it before the subroutine. Okay, so this is not going to be executed now, but I need to compare the values. Okay, I'm done. Now I'm going to execute this. Okay, once I execute, before execute, let me open a transaction called SM66. The transaction where you can able to see the processes, okay, how it is running processes, and click active work process. So currently it's 3, nothing is ours. Okay, so let me execute my program. Okay, and it's going to be 2 lakhs times. Okay, it's fine. Execute, then go to SM66 and refresh. The test system is takes them. Yeah, here it is. So these are the mine. SAPL ZJIPP 1, 2, 3, 4, 5. I hard coded 5 processes. So it decided to take the 5 process, meaning it got initiated also, but it's running. Okay, process ID is running, and refresh. Okay, it's done. Then let me go back. I think I don't have. Oh yes, I don't have any write statement. 1 second. Everything is done here. Okay, let me have a write statement. Describe table IT final lines data. Okay, there is no add symbol because this is not a select. Data LV total lines, right? Total lines. Let me go with final lines, because I'm not sure whether I have used the same name before this program. Final lines. Back to it. Execute and go here. Refresh. It's running. Still is running. Refresh. You can see this is the name of the program, so you can understand. So this is still is running. It's a little slow, the rental system. So refresh. Okay, few are done. Only 2 are running. Refresh. All 3 are done. So go back. So you'll get 46 lags of records got executed. Let's see in the debugging mode. Where it is starts from here, right? Okay. And again, I'm saying the segregation logic is it's up to you. You can do how it's feasible for your requirement. So now this is okay. I don't want this GDV count and all. Let's delete it. My source table is exactly 46 lakhs record. So I needs to be, this is the source table. It doesn't have a material description and everything. So you have material, box, works, and LGORT. And if you see the final table, it has additional fields. It has material description, box name, works name, storage location, and its storage location name. Okay, so this needs to be filled for all the 46 lakhs records using parallel processing. Let's see one by one. Let me have a breakpoint here. Okay, so AKP source has 46 lakhs records. So total number of records is 46 lakhs, and then is going to be how many packet count we decided. It's 5, so it's almost going to be 9,20,000 records. It's going to be decided for each packet. So what I'm going to say the information is just delete from 9,20,000 plus 1. Okay, because I want exactly the first 9,20,000 records, so that's the reason is adding the plus 1 here. And this is another important internal table packet. This is the actual internal table which carries the data. So here the delete plays a major role and it segregates the data, and the first 9,20,000 record is going to be passed for my first process. Okay, so task name is PO1, so just for your reference, and execute, just press F6. It's executed because it started in the another process, just as come out of it. And here it's going to be delete my source. So source, what I'm going to do is I'm going to delete this from the source first 9,20,000 record, because this was processed in my first process. So first set of records to be deleted. So delete from 1 to that level. So it's getting changed here. Okay, so first set of records got deleted in my source. This is going to be a loop. So what happens, let's see one by one. And this is now I am in my second one. So it's going to be happen. So this is not going to execute now because we decided how many records to be deleted. So this is going to be the third one. Sorry, second one. And second one also the same packets detail is going to be happening. And now the task name is PO2. Okay, I'm going to execute a little faster. So F8 comes here, and it's going to be happening one by one. So this is task number 3. Yes, F8, and then task number 4. Yeah, task number 4, and then is going to be delete. Let's see what is the data in my source. Is going to be 92 exactly last things like last 92, the 9,20,000 record. It's came here. So what happens if I go back, and it's going to be executes, this else is going to be triggered because total number of records is equal to your lines to be deleted. So total number of records is equal to your lines to be deleted. So if that is the case, I'm going to use clear. Okay, so clear my lines to be deleted. So what happens if it is clear, it is not going to do anything with the packet. It's going to be have exactly the 9,20,000. So here is everything is what you called exact data for the volume of data is exactly because it's done by myself, like do 2 lakhs times. So sometimes you will get some numbers, right? Like 101, 103. It depends on the data volume. So whatever is less than that, so just go ahead with that final packet. Okay, so this is my last one. Okay, so this is my 5th PO and it's going to be executed now. 5th task is going to execute it. And what happens now is going to be lines to be deleted is initial, right? This variable is got cleared in my previous coding. So what happens? It comes to the else part and clear the source. If the source is empty, come out of the loop. Simple. It takes some time. Let me wait. So lines to be deleted is 0 now. Here it is at 0. So what happens? It goes to the else part and delete the source. Once it is deleted, you can come out of the loop. So exit from the loop. Now, once you exit, so processed is still 0 and initiated as 5. So the cursor comes to wait until statement and it gets waited until this particular statement gets true. So it's waited. I'm just press F6 or F5, whatever it is. Once it is done, then automatically control comes to number 67. It's done because all the process also completed. Now if I go to describe table IT final, it's there already. Yeah, here it is. So it has exactly the same data from the source along with the additional information. Material details, and material details, company code name, plant and plant name, storage and storage location name. Okay. So this is how the parallel processing is happening. One of the way I can say is one of the way to increase the parallel processing. So main idea is keep the particular set of statements in your function module which needs to be, okay, it's closed, which needs to be executed in multiple sessions. So that is the main idea. You have to decide, because mostly parallel processing is going to be the existing code. So you need to identify which set of code is going to be executed in parallel. So that is very, very important. Okay. So that's it. What I have to show you else. Okay, I'll show you in the SAT transactions. So I showed SM66 I showed, and yeah, I need to show either SC30 or SAT. What I can do is, let me execute this program without parallel processing. 1 equal to 2, where it ends here. And if, and I'm going to execute this. Let me have this line at the end. Okay. So I'm going to test this, means I'm going to execute this from SAT transaction. This is, I'm going to do it without parallel processing. So I comment in the sense I use this logical condition, so it won't work. So let me go to a SAT transaction, and then yep, program. This is the program name. Exactly, this is a program name, and I'm just going to click execute. So it takes some time, and in the background it's going to gather all the runtime analysis data. Especially we are going to see the total count, means the number of time it's just taken for running the program without parallel processing and with parallel processing. And here is not going to be a much difference. The reason behind is maybe the data I manipulated up to some lakhs of data, but the data manipulation concept loop inside the loop, the doing the read statement are very, very less. Normally in real time inside the loop, maybe some conversion routines are there, or very big logic they may added it, they may a lot of performs like subroutines. So everything might be there, right? So it you can see much difference if you have a large volume of data along with more complex logics. Okay, so here it's very simple. So here the data is also correct, exactly 46 lakhs of record, and just go back, it go to the SAT, because we started with SAT transaction, and the code, this is I'm going to consider. So it's 46, 685, 463, some values. That's fine. And let me go to the program and enable the parallel processing and disable actual one. Execute it, sorry, active audit. Okay, let me open another session for SAT, because it's easy to compare. So let me go with SAT. And no change here, everything is fine, execute. So now I'm executing the program with parallel processing. Once it is done, we'll see the count actually, what is the difference. There may be a difference. Let's see how it goes. It's done. Let me go back. It's getting the data. And it's 20. And if you open the SAT for where I am, this one, yeah, so it's almost double the normal one. Okay, so it's executes. Okay, you got it already, right? It's a little difficult. So here it is 46, 685, 463 without parallel processing, and with parallel processing it's 20, 606, 146. So it's actually is a good one compared to the normal without parallel processing. Okay, so this is a way to you can justify the microseconds, how much, what's the difference before and after parallel processing. I believe that's it. One second, let me cross verify. Yeah, one more. Here it is. Instead of hard coded the process, you can get the process, okay, using some function module. Make sure how many free process are available for your parallel generate, for your group actually. So that is nothing but this one, SPBT initialize, the function module which returns what is the maximum group, what is the maximum work process is available. So here give the your group name parallel process. Let me I'm not sure, I forgot processor. Okay, this one, just give the group name. Okay, and I want this free. If you want a max also you can get it, but I go with the free work process. I need to declare this. It's going to be one integer variable, gv what process, free work process type I. Okay, that's it. And after this you have an option, either you can decrease, like if you say 5 process, maybe basis advice better you go with 3, not go with 5, so just less than 5. So you can do like g work process minus whatever information you want, otherwise do as it is, whatever is free you can use as it is. So here I'm going to use that free work process. Okay, let me show you in the debugging mode how it works. Suppose if the free work process is less than what you are looking for, then wait. Okay, then execute, wait for some time, or you can do it again. So now you have 6. Okay, so if you execute, what happens? Last time it's 5, now it's 6, so it will execute more faster. Okay, so this is the actual dynamic way to decide the process instead of hard coded one. Everything depends on your need and your scenarios. Okay, and that way it's going to be happening in my data segregation also, because now the data segregation is, let's see how is going to happening here. So now I'm going to send with this 8 lakhs record instead of 9,20,000 record last time. Now it's 8 lakh because I have more processes. Okay, so this is one way, and then also here you can able to decide when you want the parallel processing exactly. So sometimes if you see if it is reaches more than 1 lakh, then you can go ahead with this. Otherwise, what happens? If less than 1 lakh, it goes and it will execute with only one process. Everything is done. Okay, so that also you're able to make it. Just press F8. Okay, and one more is, so here also you can make a decision. So if total number of record is greater than 1 lakh, okay, sorry, 10,000, and what I'm going to do is, suppose if I'm going to use only one, so only 23 records is going to be here. So if it is 23 records, why should I go with the parallel processing concept? Okay, so let's see how it works. So if I F6, so whatever it is, and total records is going to be 0. So total number is now it's 24 records. Okay, 24. Probably someone has created, because it actually 23 and one PO got created, I believe. And then F8. So this is not going to fill, right? It's less than. And total packet is going to be carried all the 24 records. And go here and task count is also okay. Task name is PO01. Okay, F6. One process is get generated, and here what happens, it's going to delete the source also, because it is very less, right? It delete all the information, then it's come out of the execute your do loop. So it's nothing but only one is got initiated and processed. 0, it's wait until it's getting processed. Yes, it's one is processed. Okay, so here we used only one process. So mostly just go with this also, like if it is very less data, please don't use parallel processing unnecessarily. Okay, hope this might be useful for you, and just play around. If you have any doubt, please let me know. I'm happy to help. Thank you so much for your time. See you in the next video. Bye.